Hello students, today I'm going to teach you some natural phenomena. This is the chapter 12 of your NCERT. Okay, so in this chapter we are going to discuss about two destructive natural phenomena. One is lightning and the other is earthquakes. Right? Now we will discuss about what is lightning, how does it occur, what are its destructive effects and what are the safety measures. Okay, and same goes for the earthquake. So let us start. Now, lightning, you might have seen sparks in some part time of your life, right? If you put a plug which is loose into the socket, you may see a slight electric spark coming out from there. Okay, so these electric sparks is also observed during lightning, but they are on a huge scale. So what you can say is lightning is also an electric spark, but on a huge scale. All right. Now, in ancient times, people didn't know about lightning. They did not understand why, what is the reason of this spark. So they were very afraid of lightning, and they thought that it was, some kind of anger of God, which was visiting them. So they considered it this way. But now we know that why lightning occurs. So basically, lightning is due to the result of accumulation of charges. Okay, so now we are not afraid of lightning. We know the reason, and we also know how we can, what are the safety measures or precautions we can take to protect from these deadly sparks. Okay, let us read a bit of history about lightning and understand it also. The sparks that Greeks knew about. The ancient Greeks knew as early as 600 BC that when amber is a kind of material, okay, amber is a kind of resin, okay, was rubbed with fur. You're rubbing amber with fur. What happened? It attracted light objects such as hair. Okay, you must have experienced a similar thing when you rub a comb through your dry hair and bring that comb near the pieces of paper. You see the pieces of paper gets attracted towards the comb, right? You done this? If you have not done this, try this at home. Take a comb and just brush it through your dry hair. When you brush it through your dry hair, just immediately bring it near the pieces of paper. When you bring it near the pieces of paper, you will see that pieces of papers are getting attracted towards the comb. Actually, let me show this to you. Let me draw and show this to you. Suppose you have a comb like this. My drawing isn't very good. Please pardon me for that. Now you brush it through your hair. So suppose the comb gets negatively charged. Why is the comb getting charged? See, whenever we rub two objects, charging there can be charging due to friction. Charging can occur in various ways. Okay, one is friction, one is conduction, one is induction. While I'll teach you, I'll just explain these to you in little details. Okay, so this is when you brush the comb through your dry hair, you charge the comb by the process of friction. Okay, so this becomes negatively charged. Now when you bring this comb near the pieces of paper, what happens? Opposite charge is induced in these pieces of paper. Okay, so if the comb is negatively charged, the pieces of paper becomes positively charged, and we all know opposite charges attracts, right? So these pieces of paper gets attracted to the comb. Is it clear? So this is how charges work. Okay. So here let us come back to our topic. So we are talking about, you might have seen that when you take off, like winter season, when you wear woolen or polyester clothes, and when you take them off after a long time, you see your hair stands on end, right? Or sometimes in dark, if you are taking out your clothes, your woolen clothes or maybe polyester clothes, you can hear a slight crackling sound. Even children, when they play on slides during winter, So when they are slides are usually made up of plastic fibers, right? So when they slide on it, they are rubbing their body against the slide, and then if they touch something else, there can be, a crackling sound coming from them. They can feel that electric, you know that shock, slight shock, that is due to accumulation of charges. Okay, so in 1752, Benjamin Franklin, who was an American scientist, he showed lightning and spark from your clothes are essentially the same phenomena. Same phenomena as in it is also a result because of the accumulation of charges. These sparks are this lightning, this electrical spark, this crackling sound is because of the accumulation of charges, right? However, it took 2000 years for the realization to occur. So he gave a hint that this is due to this, but the entire thing was not very clear by then. It became clear how many? 2000 years later. We shall now study some properties of electric charges. Let us see what are the properties of electric charges, how many kinds of charges exist. Okay, so we have some games and activities over here. Before we enter into these games and activities, let me discuss with you the type of charges. See, charges are basically of two types. You all must be knowing, right? Positive charge and negative charge. Negative charge and positive charge. When there is an excess of electrons, then the body is said to be negatively charged. When the body has a deficiency of electrons, that means we say that the body is positively charged. Okay, so there are basically how many charges that exist? Two types of charges are there. Okay. Now, how can we charge a body? Like just now, I told you that if you brush your comb through your dry hair, the comb becomes negatively charged. Or if you're rubbing amber with fur, you're saying the charges are getting accumulated in them. One is becoming positively charged, the other is becoming negatively charged. So this is charging by rubbing, or it is also called charging by friction. So let us see, there's an activity. Let us go through this activity. Take a used ball pen. Ball pen, you all know, ball pen has a riffle. Okay, so take a used ball pen, take out the riffle, and sorry, and rub it vigorously with a piece of polythene. Now bring it to near the small pieces of paper, and just take care not to touch the rubbed end of the riffle with your hand or something. Otherwise, these charges will flow. Charges flow if they come in contact with a conductor. Okay, so don't bring it near your hand or any metallic object. Okay, so you repeat this activity with small pieces of dry leaf, husk, and mustard seeds, and then record your observations in the table which is given over here. What happens when you are rubbing polythene with woolen cloth, polythene, woolen cloth, dry hair, balloon? Okay, so you're rubbing these objects and you're using these materials for rubbing. You find out, this is an activity for you, find out if they attract, if they don't attract. What happens? They are charged, or they are, if they attract, that means they are charged. If they don't attract, that means they are not charged. Okay, I hope this part is clear. Now, types of charges I've already discussed with you. There are two types of charges, positive charge and negative charge. Let us see this activity. Now, in this activity, they have taken two inflated balloons. What they have done, they have hung them in such a way that they don't touch each other. Now, rub each of the balloon with woolen cloth and just hang them as it was. You will see that when you're next time after rubbing with the woolen cloth, when you're hanging the balloon, it is no more lying straight like this. It is now getting repelled from each other. Okay, so why is it happening? Because when you rubbed the balloon with a woolen cloth, what happened? They became charged. So you have rubbed this balloon with a woolen cloth, and then you have rubbed this balloon too with a woolen cloth. So they have developed similar charges. Maybe both have developed positive charge or both have developed negative charge, but they will have same charges. And because they have like charges, what does like charges do? We all know like charges repel each other. So here also like charges will repel each other. And because like charges repel each other, these balloons are going away from each other. Here it is written. Like charges repel each other. Okay. So you can repeat the same activity with pen refills. You rub one refill with a polythene and place it carefully in a glass tumbler using a tumbler as a stand. Okay, you see this here, and bring another refill which is rubbed with polythene again. You see, both the refills are going to repel each other. Why? Because since you have rubbed both the refills with polythene, they have developed like charges. Like charges as in either both have become positively charged or both has become negatively charged, because of which they are repelling each other. Is it clear? But now if you bring a balloon near the refill, the balloon may be having another charge, the refill is having another charge because you rubbed the balloon with a woolen cloth, and you rubbed the refill with a polythene. So they have developed opposite charges. Okay, or you can say they have developed unlike charges. So unlike charges, they attract each other. So here you will see that the refill and the balloon is attracting each other. So two main, why have we learned this? From here we come to two conclusions. We get two knowledge. Number one is that there are two types of charges that exist. One is positive charge and the other is negative charged. Okay. The second conclusion that we made is about the properties of charges, that like charges repel each other and unlike charges attract each other. So it is very much evident and clear with the activities. Okay. Now you see, let us read through this. Can we also see that charges of same kind repel each other? Yes, obviously. While charges of different kind attract each other? Absolutely. So it is a convention to call charge acquired by a glass rod when it is rubbed with silk as positive. So whenever you are rubbing a glass rod with silk, then glass rod will always, please remember this, it will always acquire a positive charge. Same way, when you rub a plastic comb through your dry hair, then the comb always becomes negatively charged. So it's a convention. Okay. It is observed that when charged glass rod is brought near charged plastic straw rubbed with polythene, there is attraction between the two. Now, what you can say if there is attraction between the two? If you're bringing a charged glass rod, we just saw that the charged glass rod is positively charged. Now you're bringing it near the plastic straw and they're getting attracted. So plastic straw must be negatively charged, and that is why it is getting attracted to the glass rod. Is it clear? So what do you think? What would be the kind of charge on the plastic straw? It has to be a negative charge. Why? Because the glass rod is positive and this is showing attraction. That means the plastic straw must be having an opposite charge, that is a negative charge. Clear? So one more thing over here, that when we are, charges, they can be, or when we will go to higher classes, we will study about two types of electricity. One is static electricity and the other is current electricity. Now what is the difference between static electricity and current electricity? In current electricity we study about moving charges, okay, and in static electricity, we study about charges that are at rest, that are static. Okay, so here what we are studying, these electric charges are generated by rubbing, and these charges which are generated by rubbing are static. So this is a part of static electricity. They do not move by themselves. Okay. Whereas when charges moves by themselves, then what do we call them? I just told you, electric current or current electricity. All right. So when you see the bulb is glowing, or when we, light up a torch or something, that is current electricity. Okay. Now let us discuss about how charges can be transferred. For that, we have an experiment over here. This experiment is that of it's a setup of a simple electroscope. As you can see, figure 12.4. It's a simple electroscope. In this electroscope, to make this electroscope, what all do we need? Let us go through. So you have to take an empty jam bottle, take a piece of cardboard, okay, slightly bigger than the size of the mouth of the bottle, pierce a hole in it, take a metal clip that can be inserted through the hole, open out the paper clip, cut two strips of aluminium foil, okay, each about 4 centimeter into 1 centimeter. Now hang them on the paper clip. You can see the setup. You see, these are the two aluminium foils which is hung with the help of this paper clip. Okay, and this paper clip goes through the mouth of this cardboard which is kept on the glass jar. Okay, all right, let us go ahead. Yeah. Now charge a refill. How do you charge a refill? Take the refill, rub it with polythene. Okay, it must be acquiring what kind of charge? We just saw that the refill, when it is rubbed with polythene, it acquires negative charge. So you charge the refill, and then what do? You touch the refill with this paper clip, metallic paper clip. What will happen? The charges on this refill will travel through this metal paper clip and will go to this aluminium foil, and you will see initially those aluminium foils were like this maybe. Okay, once you touch it with this charged refill, you will observe that these paper clips fly away from each other or repel each other. So can you explain why they are repelling each other? So this is actually another way of charging. It is called charging by conduction. Charging by conduction. Also, you can say it is nothing but transfer of charges, because this refill was rubbed with a polythene and it acquired a negative charge. When it came close to this metal paper clip, these charges, because they can travel through a conductor, charges can be transferred. So they transferred through this metal clip to this aluminium foil, and in this way they charged the aluminium foil, and because now the aluminium foil is having same charges, like charges, we know they will show repulsion, so they repelled each other. I hope this part is clear to all of you, how charges are getting transferred. So let us read a bit. The aluminium foil strips receive the same charge from the refill through the paper clip. Okay, the strips carrying similar charges, both negative, each on each other, they repel each other and they become wide open. Okay, now this device can be used to test whether an object is carrying a charge or not, and therefore it is called an electroscope. Okay, so you see, if the aluminium foils are repelling each other, you know that the refill was charged. Had the refill been not charged, or maybe you must have bought an uncharged refill and touched with the metallic strip, would you observe any repulsion in the aluminium foil? No, because the refill had no charge. Therefore there's no point of transferring the charges. There was initially no charge, so no charges will be transferred, and therefore there'll be no repulsion in the aluminium foils. Okay, so by this method you can test whether an object is charged or uncharged. All right. So, yeah. So, this is all about charging. Now, suppose you have charged that electroscope. Those foil strips have charged. Now, what do you want? You want to discharge it. You want to again bring it to an electrically neutral situation. You want to discharge it. You no more want it to be charged. What do? You just touch the paper clip with your hand. Once you touch the paper clip with your hand, as soon as you touch the paper clip with your hand, what you see? You see that the foil strips collapse. Why does the foil strip collapse? Why does it happen? The reason is that the foil strips lose charge to the earth through your body, because your body is a conductor. Charges traveled through your body to the earth, and in this way the foil strips gets discharged. All right, so this process of transferring the charge, very very important. Okay, this process of transferring the charge from a charged object to the earth is called earthing. Okay, this concept of earthing will be required both in lightning, when we'll study lightning, and also when we'll study about lightning conductors. Okay, so please remember this one. Earthing is provided in buildings. Why? To protect us from electrical shocks due to any leakage of electrical current. All right, and later on when we'll study lightning, you will see how earthing is used in lightning conductors. Sorry, just a second. Lightning conductors. Lightning conductors. Okay, so now when you know what are charges, what are the two types of charges, what are the ways, we have learned two ways of charging a body. One is by rubbing it, that is charging by rubbing or by friction. Another one we have learned that charging by conduction. We have also learned how to discharge an electroscope. We have also learned how to detect whether a body has a charge or not using a simple electroscope, right? So we have also learned about the properties of charges, that is, like charges repel each other and unlike charges attracts. We also came to know about earthing, a very very important phenomena when you want to discharge a body, or if you want the charges to go to the earth, right? So now we will enter into the destructive phenomena of this chapter, that is lightning. Now, we'll go through this part definitely, but let me explain you a bit how this lightning thing occurs. Okay. Now, you see, what happens is during very strong winds, these clouds, they get accumulated with charges. Okay, so these, suppose this is a cloud, big cloud, so they already, there are charges within them, positive, negative charges are there. When they're rubbing through each other, then what is happening, these charges are getting separated. The upper part of the cloud is accumulated with positive charge, and the lower part of the cloud becomes accumulated with negative charge. Okay, and then when on the land there are tall trees or maybe tall buildings, they, because the clouds are near them, they induce an opposite charge in them. So since the lower part of the cloud is negative charge, they induce a positive charge in these tall trees or tall buildings or whatever tall things that they come near to. And because we know that positive and negative attract each other, there is a kind of electric spark that is generated because of this interaction. And this electric spark is nothing but lightning. Okay, so this is in short, I have explained you. Now let us go through the story that is given to us in the NCRT. It is now possible to explain lightning in terms of charges, because now you know how charges are produced by rubbing, right? During the development of a thunderstorm, the air currents moves upwards while water droplets moves downwards. Okay, uh, these vigorous movements causes the separation of charges. Already there were both positive and negative charges present, but because of this activities, because of this vigorous movement, the charges are getting separated. And what happens, the positive charges collect near the upper edges of the cloud, and the negative charges accumulate near the lower edges. Now what happens, there is also accumulation of charges near the ground. And what kind of charges will be accumulated near the ground? Opposite of what is being accumulated at the lower edge of the cloud. So lower edge of the cloud you can see is negative charge, so positive charge will be accumulated near the ground. Okay, now when the magnitude of the accumulated charge becomes very large, the air, which is normally considered to be a poor conductor of electricity, is no longer to resist their flow, because it's too much now, it's huge, and negative and positive charges meet, producing streaks of bright light and sound. These streaks of bright light is lightning, and that sound that is produced, that's thunder. Okay, and the process which is happening is the electric discharge. All right. So you see that the process of electric discharge can occur between two or more clouds. It can occur between clouds and the earth. So today we need not be frightened by lightning like our ancestors did. Now we understand the basic phenomena. Why is it happening? Okay. So lightning strike could destroy life, could destroy property. So there we have to take some necessary safety measures to protect ourselves. So let us see what are the safety measures we need to take to protect ourselves from this lightning. Now, suppose during the lightning and thunderstorm, first of all, though, no open place is safe. Okay, so hearing a thunder is an alert to rush to a safer place. Immediately when you hear a thunder, you see something worse is coming, immediately rush to a safer place. All right, after hearing the last thunder, wait for some time before coming out of the safe place. Okay, so remember, until unless it's not completely over, try to be there wherever you are safe. Okay, so now what kind of safe place we should look for? Finding a safe place. A house or a building is a safe place, because nowadays house and buildings comes with lightning conductor. Okay, if you're traveling by a car or a bus, you are safe inside with windows and doors of the vehicles shut. Okay, What are the do's and the don'ts during a thunderstorm? Now, there are do's and don'ts when you are outside and when you are inside. So, let us first see what are the do's and don'ts when you are outside. Remember, open vehicles like bikes, tractors, construction machineries, open cars, they are not safe for us. Any open fields, tall trees, shelters in parks, elevated spaces like mountains or cliffs, okay, they do not protect us from lightning strokes. Okay, in fact, even carrying an umbrella is not at all a good idea, because we know that umbrella, they're again a conductor, okay, right? And these charges can interact. The charges coming from the cloud can interact with it, and it can be very dangerous or fatal. If you are in a forest, take a shelter under shorter trees, not taller trees, because taller trees are under more risk. Okay. If no shelter is available and you are in an open field, stay far away from all trees. Okay. They are more likable to attract those charges. Stay away from poles, electric poles, or other metal objects. Okay, do not lie on the ground. Instead, you can squat low on the ground. See the way the person is sitting, he's squatting low on the ground. So in this way, you have to place your hands on your knee with your heads between the hands and take the smallest position for your target to be struck, because they are looking towards, taller targets. Okay, so this is when you are outside the house. Now let us see what are the precautions that you need to take when you are inside the house. So lightning can strike telephone cords, okay? It can strike electric wires and metal pipes. So just to remember, stay away from electrical devices. Okay, cordless ones you can use, wireless ones you can use, but other than that, any wired devices, just stay away from that. Okay, bathing should be avoided during thunderstorm to avoid any contact with the running water. Electrical appliances should be unplugged, like computers, TVs, ACs, ovens, these should be unplugged during thunder and lightning. Okay, and electric lights and fan, these small devices which uses less amount of electricity, they can remain on, they do not cause any harm. All right, so that was about what is lightning, how lightning is caused, and what are the safety measures when we are inside the house, when we are outside, to protect ourselves from this destructive effects of lightning. Now we are coming to see lightning conductors. Remember, they said that if you are inside houses and buildings, you are safe. Why? Because nowadays houses and buildings are provided with lightning conductors. Okay, so lightning conductor is a device which is used to protect building from the effect of lightning. And how does it look like? It is a metallic rod. It is taller than the building, and it is installed in the walls of the building while it is constructed. So during the construction process only, the building is installed with a lightning conductor. Now, one end of the rod is kept out in the air, as you can see this part. You'll see lightning conductor in many tall buildings usually. So one part is outside in the air, and the other part is buried deep in the ground, which is called earthing. Remember, we studied earthing. So the rod provides easy route for the transfer of electric charge to the ground. Let us see. Let us see the, yeah. You see this? This is the lightning conductor, and it goes through the wall deep down into the earth. You see, this way of putting the lightning conductor into the earth is called earthing. By this process of earthing, what is happening, if the clouds are coming near the buildings, and they have charges accumulated, what will they do? They will induce opposite charge in this, so this will have positive charge, and then there will be an interaction, but this interaction will not destroy the building. What will happen? The charges are going to pass through this lightning conductor, where it is going to go to the earth. Okay, so again, earthing is actually a safety measure. Okay, so you're transferring all the huge amount of electric charge to the earth using this lightning conductor. Is it clear to all of you? Lightning conductor is a very, very important topic for your syllabus, so you should know what is lightning conductor. Clear? Now we will come to the next destructive phenomena of this chapter, that is earthquakes. Okay, so we have learned about light, thunderstorm, and lightning. Now we know that obviously these natural phenomena, whether it is lightning or it is earthquake, they cause large scale destruction of human life and property. Fortunately, these phenomena can be predicted to some extent, not always. Okay, some extent the weather department can tell you that there will be a huge thunderstorm in some area, there can be a cyclone struck region. Okay, so this is, a bit of prediction is there, but earthquakes are actually not very predictable phenomena. Okay, lightning, we can still take necessary precautions. If we know that this area is going to be hit by a cyclone, we may take some safety measures from beforehand to prevent a large scale destruction of human life and property. But when it comes to earthquakes, we are a bit skeptical if we can predict an earthquake, because it is not as predictable as lightning and thunderstorm. We are not yet able to predict it accurately. Okay, so this natural phenomena, we don't know when it is going to happen. So that is earthquake, and this can also cause large scale damage on human life and property. There's a major earthquake that happened in the year 2005 on 8 October in Uri and Tangdhar towns of North Kashmir. Before that, before 2005, in 2001 also, in Bhuj district of Gujarat, 26th January, there was a major earthquake which caused a lot of damage to human life and properties. Okay, they have given a very short experiment, to collect a few pictures and details from your parents about if they have encountered any earthquake during their lifespan, and what kind of destructions were there, and what was the magnitude of the earthquake, how can we minimize the effects. You can, make a small project about earthquake like this. So now let us see what is an earthquake. We know that earthquake is a sudden shaking or trembling of the earth which lasts for a very short time. But even if it lasts for a very short time, in during that short period of time, they cause a lot of disturbance and destruction. So this earthquake, what is the reason of happening? Actually, deep inside the earth's crust, there is some disturbance which leads to earthquake. This is the cause, the disturbance deep inside the earth's crust. Okay, so to understand that, we will study a bit about the layers of the earth. Okay, first let us go through this. So earthquakes, they occur all over the earth, and it occurs all the time. There's always some, disturbance in the earth's crust, which are not even noticed by us. Okay. But major earthquakes, these minor earthquakes are occurring all the time, but major earthquakes, they are much less frequent. They can cause immense damage to buildings, bridges, dams, and to the life of people. There can be great loss to the life and property actually. So earthquake is one natural phenomena which triggers other natural phenomena like floods, landslides, and tsunamis. Tsunamis are earthquake under water. So a similar tsunami happened in the year 2004 on 26th December. It was a very, it was a very devastating one. It happened near the coastal areas, and people suffered huge losses during that tsunami. A lot of people lost their life, properties, many things were, destructed and damaged. So you can again do a similar study about tsunami. Okay, in the activity 12.6. Now let us see what causes an earthquake. In ancient times, people did not know the true cause of earthquake actually. Just like lightning, they had no idea about earthquake. They had their own, mythical stories about earthquake. Like one of the stories over here, that my grandmother told me that the earth is balanced on the horn of a bull, and when the bull shifts it to the other horn, earthquake takes place. So obviously, this is too, silly to believe. So this is just a story, and there were a lot of these kind of stories in ancient times about the earthquake until people know what was the real cause. But now we know why we have these tremors. These tremors are caused by the disturbance where deep down the inside of the uppermost layer of the earth, which is called the crust. Over here, you can see we have the different layers of the earth. You please, this is an important figure 12.9. Structure of the earth is important. They may give you the structure and they may ask you to label it. So first we have crust, then we have mantle, then we have outer core, and then we have the inner core. Now, earthquake is due to the disturbance in the deepest layer of the crust. Okay, not on the in the inside of the uppermost layer. So uppermost layer is the crust. So inside, deep down the crust, there are disturbance because of which we feel these tremors called earthquake. Okay. So outermost layer of the earth is actually you seeing it as one crust, but it is not in one piece. It is fragmented. Fragmented means it's in broken pieces. And each of these broken pieces, each of these fragments is called a plate. Now, these plates, they are in motion. They are in continuously motion. They brush past one another. How? I'll show you. There's a diagram given over here. So you see the diagram. These are the plates which is brushing past each other. Can you see? Figure 12.11, the second part. They're brushing past one another. Okay, so these are the movements colliding or brushing past. These are the movement of the Earth's plates, which is continuously happening. It is non-stop happening. So, although we know for sure what causes an earthquake, still we are not able to predict when the next earthquake can occur or might occur. Tremors on the earth can also be caused not just because of brushing past of these plates, they can also be caused due to volcanic eruptions or when the meteor hits the earth, if there is an underground nuclear explosion. So all these can also be the reason of earthquake. Okay. However, most earthquakes are caused by movement of the earth's plates, these tectonic plates, you can say. Okay. Since earthquakes are caused by the movement of plates, the boundaries of the plates are weak zones. Okay, so you know what are the weak zones where earthquakes are most likely to occur. So these weak zones are known as fault zones or seismic zones. Let me highlight them. The weak zones are also known as seismic or fault zones. And what are the weak zones? The boundaries of the plates are the weak zones where earthquakes are more likely to occur. All right. So in India, the areas most threatened are Kashmir, the western and the central Himalayas, the whole of the northeast, the run of Kutch, Rajasthan, Indo-Gangetic Plain, and some areas of South India also fall in the danger zones of the earthquakes. Okay. So they have marked all the areas on the map over here. You can go through it. Now let us see uh, the destructive uh, properties of earthquake. What kind of destruction it causes. Okay, so power of an earthquake is expressed in terms of a magnitude on a scale called Richter scale. Like if you ask your parents, they can tell you about the past earthquake which has occurred. What was the magnitude of the earthquake? The magnitude of the earthquake is measured on a scale which is called Richter scale. Okay, and the more the magnitude on the Richter scale, the more is the destruction caused by the earthquake. So, really destructive earthquakes can have a magnitude higher than 7 on the Richter scale. So, we talked about the earthquakes over here, right? So, both Bhuj and Kashmir earthquakes had a magnitude which was greater than 7.5. So, higher than 7, they are going to cause really a lot of destruction. You see, there's a small portion over here which measures this earthquake, this device that measures these seismic waves. These seismic waves are recorded. Okay, so that device which record the seismic waves is called seismograph. You can see this device in figure 12.13. There is just an instrument which is simply a vibrating rod, and there's a pendulum. You can see a pendulum bob is hanging over here. Just a second. Yeah, you can see this is the pendulum bob that is hanging. Now a pen is attached to the vibrating system. You see this is the pen which is attached. Now pen records the seismic wave on the paper which moves under it, and then scientists, they study these waves and they construct a complete map of the earthquake. As you can see, it's given over here, the map they are constructing. Okay, so map of the earthquake is in similar way constructed, so you can go through this. Now we know what causes the earthquake. Okay, how can we measure the magnitude of the earthquake? So on Richter scale, and this what are the earthquake prone areas, the seismic zones, the fault zones, the border, the boundaries of the brushing plates, right? We know about all this. Now we'll know how we can protect ourselves against earthquakes. See, we already know that earthquakes cannot be predicted. It cannot be predicted. So we also have seen that they can be highly destructive. Yes, absolutely. So it is therefore important to take necessary precautions to protect ourselves all the time, because we don't know when it strikes. So we should know the necessary measures which needs to be taken if there is an earthquake. Okay, so people who are living in seismic zones, fault zones, where earthquakes are most likely to occur, should be specially prepared from beforehand, because they know that these are earthquake prone areas, and any time an earthquake can strike there, right? So all the buildings in this zone should be so designed that they can withstand major tremors. Okay, modern building technology can make it possible. There are a lot of nowadays, as we are developing, we know a lot of technologies, modern building technologies, which can help us minimize the loss. Okay, minimize the destruction caused by the earthquake. So we have to make the structure simple and quake safe. Okay, so for that, what we need to do is we have to consult qualified architects and structural engineers who are qualified enough to make the structure quake safe. In highly seismic areas, in the fault zones, in the seismic zones, the use of mud or timber is better than using heavy construction materials. Keep the roofs as light as possible. In case if the structure falls, the damage will not be heavy if you keep the roofs as light as possible, if you don't use heavy construction materials, right? It is better if the cupboards and the shelves are fixed to the wall so they do not fall easily on you or on anyone. Be careful where you hang your wall clocks, photo frames, water heaters, so that in the event they do not fall on people. Okay. Since some buildings may catch fire due to an earthquake, fire catching fire is a very much common destruction during earthquake. So it is necessary that all buildings, especially the tall ones, should have firefighting equipment in working order. It should not be like the equipments are there but they are not working. It should be in working order. The Central Building Research Institute, Roorkee, has developed know-how to make quake-resistant houses. Okay. In the event that an earthquake does not strike, take following steps to protect yourself. So again, if you're inside, if you're outside, what are the steps you are going to take if you want to protect yourself from earthquake? So if you are at home, take shelter under table, stay there till the shaking stops. Don't just move around here and there. Okay, stay away from tall and heavy objects that may fall on you. If you are in bed, do not get up. Protect your head with a pillow. Okay. If you are outdoors, then just find a clear spot. Stay away from buildings because they are, likely to be falling. There must be heavy building materials which are used there. So something may be falling on the other. Stay away from trees. Stay away from overhead power lines and just drop to the ground. If you are in a car or a bus, do not come out. Ask the driver to drive slowly to a clear spot and do not come out until the tremor stops. Okay, so these are few safety measures which we need to take. In our next classes, what we will be doing, we will be discussing the questions from the exercise. I hope you have understood the chapter. If you have any problem in understanding the details, please mention it in the comment section. Thank you.